Assalamualaikum warahmatullahi wabarakatuh. We are from group 5 and today we are going to present about motions of projectile. So now I will introduce you guys my team's members. Number 1 is Ahmad Irfan. His number metric is AA221913. And number 2 is myself, Amira Adina. My matrix number is AA220855. And number 3 is Azin Harid. His number metric is AA221508. And number 4 is Muhammad Danish Imran. His matrix number is AA221159. And lastly, Muhammad Farhan. His number metric is AA221901. And thank you. So now we will continue to the introductions. Projectile motion is the motion of an object thrown into the air when, after the initial force that launches the object, air resistance is negligible and the only other force experienced by the object is the force of gravity. An object is called a projectile and its path is called a trajectory. Air resistance is a frictional force that slows its motion and can significantly change its trajectory. Due to difficult in calculations, only situations where deviations from projectile motion are negligible and air resistance are negligible are considered in introductory physics. The most important concept in projectile motion is that when air resistance is neglected, horizontal and vertical motions are independent, meaning that they do not affect each other. Additions, there is no accelerations in the horizontal direction, which means that the velocity of the particle in the horizontal and in the particle or in the horizontal directions remains constant. We will continue to the kinetics formula, often writing as the following these equations. There is 3 formulas that we can use in projectile motion, and you can look at the slide. We will continue to the projectile motion applications. The example is throwing a ball or anything. When a ball is thrown into the air, we see that it travels some distance and then falls. When the path followed by the object looks like a parabola or a U-shaped curve, this part of path is neither linear nor circular. It is known as the projectile's motions, and the path taken by the ball or item is known as its trajectory. So, when we throw a horizontal in the air, it does a loop and that goes up and repeats as if going in parabolic pattern, and then come back down. This is due to the motion of the bullets. And thank you to listening my presentations.
Assalamualaikum and hi, my name is Muhammad Danish Imran bin Muhammad Yusuf. My metric number is AA221159. So today I'm gonna present about the question. So the question is, you throw a rock off a bridge. The initial velocity of the rock is 8 meter per second at an angle of 53 degrees above the horizontal. It takes 20 seconds for the rock to hit the water below the bridge. Number 1, how far from the base of the bridge does the rock land? Number 2, how high is the bridge? Number 3, how fast is the rock traveling before it hits the water? So next I will present about the identify and understand the problem and issues. The problem described is about throwing a rock off a bridge with a specific initial velocity and angle above the horizontal. It gives the initial velocity of 8 meter per second and angle of 53 degrees. The purpose is to determine several features of the rock's motion, such as the distance from the bridge to the rock land, the height of the bridge, and how far it travels from the bridge base to where it lands. The key problem is calculating the vertical and horizontal component of the rock's velocity. First, the horizontal component can be calculated using the formula Vx0 equal to V0 cos theta, where V is the initial velocity, there is 8 meter per second, and theta is the angle above the horizontal, 53 degrees. Similarly, the vertical component can be calculated using Vy0 equal to Y0 sin theta, where sin represents the sine functions. Furthermore, it is important to consider the effect of gravity, as it is the main force acting on the rock. Gravity causes the stone to accelerate vertically downward at a rate of 9.8 meter per second squared. By understanding this aspect, we can process by solving the problem and determining the desired outcome. So that's all from me. Thank you.
Now, I want to analyze the question. A. To start the x and y displacement magnitudes, the rock is hurled at an angle of 53 degrees above the horizontal with an initial velocity of 8 meter per second. The rock needs 12 seconds to reach the water beneath the bridge. In order to answer the question, we must ascertain how far the rock is from the bridge base. We can use the formula x equals to Vxt plus xo to answer this problem using the idea of projectile motion, where x is the rock's horizontal position, xo is its beginning horizontal position, Vx is its horizontal component of velocity, and t is its travel time. That's 12 seconds. For B, the rock's vertical motion can next be examined. We are aware that gravity is the only force affecting the rock vertically. In order to employ the formula y equals to negative 12 gt square plus v by ot plus yo, where y is the rock's vertical position, yo is its initial vertical position, vyo is its vertical component of velocity, t is its duration, 12 seconds, and g is its gravitational acceleration, 9.8 meter per second square. We must first know the rock's vertical position. The height of the bridge can then be determined using this equation. C. Lastly, since the horizontal component of the rock's velocity is constant throughout the flight, we can utilize the vertical component to calculate the speed of the rock immediately before it lands in the water. Using the formula Vy equals to negative gt plus Vyo, we can determine the vertical component of the velocity, the acceleration caused by gravity 9.8 meter per second square, the duration 12 seconds, and the beginning vertical component of the velocity. Assalamualaikum. My name is Azrin Hafiz. My metric number is AA221508. Today I'm going to present about strategizing the question. First, understand the information provided. Begin by carefully reading and understanding the facts in the question. Take note the initial velocity, 8 milliseconds, and the throwing angle, 53 degrees above horizontal. Also, take note of the fact that the rock takes 12 seconds to hit the water. Next, break down the problem. Determine the specific components of the problem that require attention. In this case, we need to know how far from the base of the bridge the rock lands, the height of the bridge, and the speed of the rock just before it hits the water. Then, use the relevant concept, apply the principles of projectile motion, to solve the problem. For the first question, we can use this formula. X equals to Vxt plus X initial. Second question, we use this formula. Y 1 per 2 gt square plus V y naught t plus y naught. And the last question, we use this formula. Vy equals to negative gt plus Vy naught. So with these formulas, we calculate the values. Next one, solve step by step. Divide the problem down into smaller steps and solve the systematically. Begin by determining the velocity, horizontal and vertical components. Finally, use the formula given to answer the question given. Lastly, verify the result. Check the calculate values and ensure it is consistent with the information provided and the problem statement.
The discussion for our topic is, we have looked at the underlying internets and properties of projectile motion in this motion for projectile. We have looked at the motion of an item that is thrown at an angle into the air, experiences gravity and travels along a curved trajectory. First, we talk about the horizontal and vertical motions that make up projectile motion. The vertical motion follows a parabolic route because of the force of gravity pressing on the object, whereas the horizontal motion is constant and unaffected by gravity. We found that the motion of the projectile can be divided into two distinct motions along perpendicular axes by analyzing the forces acting on the projectile. Conclusion: projectile motion is a key idea in physics that explains how things fired into the air move. We examine the trajectory, range, maximum height and duration of flight of a projectile by taking into account the independent horizontal and vertical motions. We have emphasized the significance of important factors in our discussion, including beginning velocity, launch angle and height, in influencing the characteristics of projectile motion. We can precisely forecast and analyze these parameters by using mathematical equations and calculations.